So between yesterday and the day before, we talked about two different ways to look at parabolas or quadratics given the format it comes in, right? So this one is in standard form. You've got the only single x raised to a power, but it's only an x. Quadratic would be the next one, which is like x squared and x. So with these, this should be like a quick, just look at your equation and pull out information like your vertex, which would be what on this one? +4 and +5. And then your intercepts, for your x-intercept, I would say 0 equals x minus 4 squared plus 5. When I subtract the 5 from both sides and then try to square root it, I get the square root of a negative number. It's an imaginary number. We can't graph imaginary numbers, right? So there would be no real solution. So there's no x-intercept. And then your y-intercept, if I plug 0 in for x, y equals 0 minus 4 squared plus 15. I get negative 4 squared, which is 16, or sorry, plus 5, not 15. Plus 5, which is 21. So x-intercept doesn't exist. Y-intercept is 0, 21. How do I know if my graph has a max or a min? Which direction it opens, right? So this one opens in which direction? Up, which means it has a min, and the minimum value would be the k coordinate of your vertex, right? Which is? 5. So it has a min, and that min is 5. Okay? Be careful, don't give me 4 or 5. An absolute max or min is just the y coordinate of your vertex. And then it says graph your function. So I've got 4 or 5 to go on. I know this opens upward. And I know my y-intercept is like 0, 21, which is like all the way up here, okay? I don't have anything on the right yet. I could actually go up and over the same distance to the right as I did to the left. That's one way to do it. But if you don't want to graph that 21, then you can just plug in a point from the left and the right of your vertex. So if I plug in 3 and 5, I would get 3 minus 4 squared plus 5, which is negative 1 squared plus 5, 1 plus 5, which is 6. And if I plug in 5, I should get the same thing because I went over the same distance. 1 squared plus 5, which is 6. What would domain and range be on this function? What's domain? Domain on any parabola, right? All real numbers. What's range? Nope. What's the lowest point? This one has a stopping point, right? 5 to positive infinity. So your k coordinate of your vertex is obviously in the vertex. It is your max or min, and it is your range, okay? It is going to be the start or the stop of your range, depending on whether your graph opens up or down. Okay, so then this one says find the vertex of the function 4x squared minus 4x plus 21. So the first way you can do this is negative b over 2a, and honestly, because there's something in front of the x squared, if I had a choice, that's where I'd go. So my a is 4 and my b is negative 4. I do negative 4 over 2 times 4. Okay, the 4s are going to cancel. Negative 1 on the negative 1 times negative 1 on the top is a positive 1, and then 2 in the bottom. So that's the h coordinate of my vertex, and then I got to take and plug that back in to get the y. So 1/2 squared minus 4 times 1/2 plus 21. 4 times 1/4 minus, this is 2 plus 21. This is 1 minus 2 plus 21, negative 1 plus 21, which is 20. So that's one way to do it. I'm going to work through the complete the square process because we haven't done one together that has a number on the front, okay? I did a video that's separate that has 3 examples in which none of them have 1 as the x squared. So if you need to watch the review for complete the square, it says complete the square extra practice problems. It's on the YouTube channel, okay? I'm telling you right now, you're going to get a question on your quiz that is forcing you to complete the square, and it is not an x squared equals 1. So it's coming. You got to know how to do it, okay? So the first thing you have to do is group together your 4x squared and your 4x. So 4x squared minus 4x, leave the space, bump the 21 to the outside. Now, if there's something in front of the x squared, God bless you, it's got to come out. When I take out that 4, not only does it come off the a term, but it also comes off the b term, which means this becomes negative 1x. So then I would take that middle term, which is 1, I would divide it by 2, and I would square it, and I get 1/4. That's what I add inside the parentheses, and I would subtract from outside the parentheses. You with me so far? So if there wasn't a number in front of the parentheses, I'd just add or subtract that 1/4 off the 21, and I'd be done after I factor. But because we took a number out, and that number would technically get distributed back into that 1/4, we account for it by multiplying it by the negative 1/4 before we combine that with the 21. So whatever comes out has to get multiplied by what you would be subtracting off the end. So this becomes -1. 4 is still in the front. X squared minus x plus 1/4 plus 20. I've made the middle my perfect square trinomial, which means I can use the shortcut to factor. Square root the first term, square root the last term, take the sign from the middle, put it in parentheses, square it, and then don't forget your plus 20. So now compare this to what I got from my vertex at the beginning, right? The vertex here, this would be 1/2, 20. You should get the same answer either way, and if you have extra time, that's how you check it. Yes. No, you don't have to do both. So on your quiz, well, you do have to, not within the same question. So on the quiz, one question is going to force you to do complete square. So it's going to give you an equation in quadratic. Say, put this in standard form. Then you get one that says graph, and you get to choose. Do you want to put it in standard form? Do you want to keep it in quadratic and do negative b over 2a? That's your choice. Yep. Questions? All right, so this was number, 7 for my homework, okay? So everybody might have had different numbers on the side, like where it's red, obviously. But it said to make a sign holder, you bend 96 inches long steel wire, 8 inches from each, x inches from each end to form 2 right angles. To use the sign holder, you insert each end 4 inches into the ground. Write a function for the rectangular area enclosed by the sign holder. This is a rectangle. How do I find area of a rectangle? Length times width. So I had to do 96 minus 2x times x minus 4. So I had to do 96 minus x minus 96 times 4, 24, 384, plus, no, sorry, minus 2x squared plus 8x. And then I had to add these two, which is weirdly where a lot of people made mistakes, not necessarily these numbers, but in that adding process, which is 104x minus 384. So that is your area function, okay? Then it said, use the table feature of the graphing utility to determine the value of x that maximizes the rectangular area enclosed by the sign holder. This is a great standardized question, which is why I gave it to you. Okay, so what you need to do is type that in to your graphing calculator. So negative 2x squared plus 104x minus 384. It looks like this, right? That is a huge graph because just think about your y-intercept. What would be your y-intercept? Negative 384, right? So it's not even on my screen, which is why it's saying use the table. Don't keep zooming out, zooming out, zooming out, zooming out. It's going to be a lot of work, okay? But if I use the table feature, so if I go to table, which is above the graph, second table, I get this, okay? So I'm looking for a maximum value for y. How do I know it's the maximum value? It's the highest y. So if I just keep arrowing down, 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 pay attention to your y's. It's going up, 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 going up, going up, going up, going up. And then all of a sudden it starts to come back down again. Does everybody see that? So I'm looking for my maximum point which is 968. That's the maximum y. But what this question is asking is for what? The x coordinate that gives you the maximum y. So the x coordinate would actually be, in this case, 26.
Wait, how do you know it's the x coordinate?
Because how do I know from the question? The question literally said, determine the value of x that gives you the maximum result.
Okay, so you just find that from the table.
Yep, and this is a really good standardized question because that's what you have to pay attention to, the wording on it, and also apply what you know about parabolas, okay?
Can you show me on the table for that?
So chapter 2, section 2 is called Polynomial Functions of Higher Degree. We're going to basically learn how to graph functions that have things like x to the 4th and x to the 5th and that kind of thing in them, okay? We're moving on past the past the quadratics, and we're getting to ones that are a little bit higher. So almost like taking what you just had in your calculator portion of your test and learning how to graph that by hand. That's the idea behind it. Now, functions of degree 2 or higher have graphs that are smooth and continuous. Only rounded curves, no sharp corners. That's what makes them smooth. And there's no breaks from the start to the finish. So your graph can be drawn without lifting your pencil or your stylus from the rectangular coordinate system. So from start to finish, you'd never have to leave your screen. So what you will see is stuff like what's on the left. These are smooth, these are continuous, they're not sharp corners. What you won't see, or if you do see it's wrong, is the stuff on the bottom right, okay? There should be it's not a piecewise function anymore because that starts and stops, okay? Or it gets sharp edges where it changes from a parabola to a different parabola to, that one's like 4 parabolas put together, okay? It wouldn't be anything that has the sharp curves like this. So all of your graphs should look something like the top left, where it's continuous and smooth. So if you're graphing a monomial, which is a single term, you have a single x, and n is the exponent on that x. If the n is even, the graph resembles that of the f of x equals x squared, or your parabola. If the n is odd, then the graph resembles the graph of x to the 3rd power, your cubic function, which points up to the right and down to the left. And the greater the value of n, the flatter the graph is near the origin. So you won't see too many of these that like ask you to graph them exact, but this is a great scenario in which it could be, the first question you've got is like matching. If you're trying to compare an x to the 2nd and an x to the 5th, or an x to the 2nd and an x to the 6th, okay, you would want to know what they look like. So if I just graph f of x equals x squared, let's say, then I'd have a 0, 0, I'd have a 1, 1, a negative 1, 1, a 2, 4, and a negative 2, 4. This would be what my graph looks like. And then if I had x to the 4th, I have the same exact center point. I have the same exact point at 1 and negative 1, okay? But what happens when I go, like, say I plug in 2 to the 4th?
Go to the 4.
You're going to go up fast, like it's going to go up faster, right? So like 2 to the 4th becomes 2 times 2 times 2 times 2, right? Or 4, 8, 16. So I'm going to increase faster when it goes up this way and this way. But what it's saying about it being flatter in between is what happens in here, okay? So think about if I pick a number from in here. Let's say I pick 1/2. If I did 1/2 squared, I get what? 1/4, okay? If I did 1/2 to the 4th, I get 1/16. So what's happening is in between here, these points become flatter. That's all you need to know, okay? And you don't even have to find those exact points. This is going to be, we're going to do some transformations with this stuff. You just have to know if you compare an x to the higher power, like an x to the 10th, to an x squared, that in between your origin and the first point, it's going to flatten out. Same thing with an x cubed, okay? So where an x cubed would be normally 0, 0, 0, 1 like this, an x to the 7th, let's say, is going to flatten out more around your origin. It's never going to become constant, okay? It's never going to become horizontal, but it will get closer to your axis than your x to the 3rd, okay? So again, that would just be for comparison purposes. Like I'm not going to make you graph an x to the 7th with no other information, okay? You can just do transformations. So think about what's happening here with these. Sketch the graph. So f of x equals x to the 7th plus 1. 7 is even or odd? Odd, which means it's going to resemble which graph? X to the third. And the plus 1 is doing what? Good, up 1 unit. So it's going to be like this. It's going to be a little bit flatter and a little bit stretched on the outsides. Something like that. Doesn't have to be exact for these. X minus 1 to the fourth. So which graph is this going to resemble? X squared, or my parabola, and the minus 1 inside the parentheses? To the right one. So it's just a little bit flatter in between the 0 and the 1, and then it's going to go up faster on the outside. So these are just approximations. As soon as I start to add in extra x's, like if it was x to the 7th plus x to the 5th minus x to the 3rd, something like that, that's when you start to get those bumpy curves, which we're going to learn how to graph, okay? But for now, these are just monomials, so one single x. All right, so the leading coefficient test, and this is like a lot of stuff. This is what your book. This, I feel like my job is like interpreting from math speak to like normal talk, right? So this is what your book says. So the leading coefficient test is what we're going to use, okay? It basically tells you to look at the highest exponent in your equation, which is going to be n. Determine if it's even or odd. That's the first thing you want to do. If it's even and the number on the front of it is positive, both of your arrows are going to point up. If it's even and the number on the front of it is negative, both of your arrows are going to point down. If the highest exponent is odd and the number is positive, it points up to the right, down to the left, just like your x to the third. And if it's odd and negative, it points up left and down right. So that in regular terms looks like this. There are two types of degree polynomials with n behavior, odd and even, okay? If the highest degree, so you're always looking at the highest degree, well, you're always looking at the degree which is the highest exponent. If the highest exponent is odd and the number on the front is positive, then the graph falls left and rises right. So if I had something like 3x to the 5th, okay? Highest exponent is odd, number on the front is positive, which means my graph is going to rise to the right and fall to the left. What happens in between is what we're going to figure out. But for now, we're just doing n behavior. If the highest exponent is odd and the a is negative, then the graph rises left and falls right. So in this case, it'd be like a negative 3x to the 5th. And this one is going to rise to the left and fall to the right. Oh, that arrow should be on a different spot. Hang on. Okay, the other option is if it is even. So if the highest exponent is even and the number on the front is positive, which would be like a positive 3x to the 6th, then they both point up. So it rises left and rises right. If it's even but it's negative, like a negative 3x to the 6th, then they both point down. Okay, it falls left and falls right. So when you get to like the first question in your homework and you're matching a bunch of graphs, you could probably narrow down almost half of them by just looking at n behavior. You can look at the monomials, figure out which one those are supposed to look like, and then go to the ones that have extra x's and say, okay, if it's supposed to point up right and down left, I know I can narrow this down. Okay, there's so many things that you can use to help you process of elimination. All right, so these, again, should be quick, require no work. You just have to look for the highest exponent and then figure it out from there. So use the leading coefficient test to determine the end behavior of the graph. What's the highest exponent of my function? 3. So this could be in any order. This could be negative 4x minus 3x to the 3rd plus 7. I'm always looking for the highest exponent. It won't necessarily be first, okay? So highest exponent is 3, which already tells me what? That's odd. One's going up, one's going down. Now I look at the negative on the front, which says it's rising first. So it's rising left and falling right. When I go to draw this, that means that my left arrow is going down, up, and my right arrow is going down. And then I have to figure out what happens in between. Zeros of a function, which we have now seen a million times, right? In a polynomial function, the values of x for which f of x equals 0 are called zeros of f. They are also known as roots, solutions, or solutions of the polynomial equation. And each real root, of the polynomial equation appears as an x-intercept of the graph of the polynomial function. So we're going to take our equation, we're going to set it equal to 0, we're going to factor it if we need to, we're going to solve it, we're going to figure out what those roots are. First example, so all zeros, and this one's already set equal to 0. You could see it as this plus 2x to the second minus 4x minus 8 equals f of x. And you have to know that finding the zeros means making f of x be 0, okay? So what do we do when we have 4 terms? Group them. So I'm going to group these two together. I'm going to group these two together. What can you do with the first set of parentheses? Take out an x squared. What can I do with the second set of parentheses? Take out, you're all right. Yeah, you can take out a 4, you can take out a negative 4. Let's try 1. Let's see what happens if I take out a 4. Then I get negative x minus 2. So my goal is for what's inside the parentheses to be the same, right? Exactly the same, which means I need to make that a negative 4. Good. So I'm going to go back and change this to negative, which changes my signs. So negative 4 would be a positive x and a positive 2. Now what's inside the parentheses is exactly the same. That's going to come out as my first parentheses. And then what's grouped together, it comes from what's in the front of the parentheses. Is that factored completely?
No.
No, I can do one more thing, which is what? Different than 2 squares. Okay, if you didn't catch it, then when you go to solve it, you should get the plus or minus root 4, which will take care of it. But if you did, go ahead and factor it. So now I set each of these equal to 0. And I get x equals negative 2. I get x equals negative 2 again. And I get x equals positive 2. With me so far? Yeah. So when I list my roots, I don't have to list negative 2 twice. But in a minute, you're going to see why that's important. It's important to identify that it happens twice. Okay? So I do negative 2 and 2. When I list my roots, I list them. So these are not points. So some of you still did on your test yesterday. If I want the roots, I don't want them in coordinate point format. I want you to list them. Questions so far? Okay, so there could be all types of factoring in there. Okay, there could be 3 terms with a number in the front. There could be perfect square trinomials. There could be factors like this. There could be ones in which you have to like take out a greatest common factor first and then do it. Remember, there's a there's a factoring video on iTunes if you need it. Watch it. Eventually, we might even get some that are like quadratic, which would be, you'd end up doing, but we'll get to that. Quadratic formula, you could always do that. Okay, so this is why it's important that something occurs more than once. The multiplicity of a root, or of an x-intercept, is if a root occurs more than once. So if it just occurs once, we just list it. But if it occurs more than once, the multiplicity of that root is the number of times a root occurs. If it occurs an even amount of times, then it's going to hit the x-axis and change direction at that point. So it bounces off. If it's an even amount. And if it occurs an odd number of times, then it crosses through the x-axis at that point. Okay, the last thing that we're going to use to graph is turning points. So the number of turning points determines how many times it changes direction on my graph. Okay? If a function is a polynomial function of degree n, so again, n, highest exponent, then the graph has at most n minus 1 turning points. Important to pay attention to the words at most, okay? Doesn't mean it has exactly that many turning points. It means it can't have any more than that. So your turning point is every time it goes up and comes back down, down and comes back up, every change of direction. If you look at the graph that's there, that's f of x equals x to the fifth minus 6x to the third plus 8x plus 1. What's your n on that function? 5, which means it can have 5 minus 1 or 4 max turning points, okay? So here it goes up and comes back down. That's 1 turning point. It goes down and comes back up. It goes up and comes back down, down and comes back up. So this would be my second turning point. This would be my third turning point. And this would be my fourth. So again, this is great to use in a matching scenario, right? If I have an x to the third and I look at the graph options, what's the most amount of turning points it can have? 2, okay? So you can process of elimination, rule some stuff out. Combine that with your end behavior, and you're probably going to be able to narrow down a lot. All right, so this is going to kind of put it all together. Find the zeros, determine the multiplicity, determine the maximum possible number of turning points, and use a graphing utility to verify. This should look familiar. We've already factored it, right? This is from the first example. What did it look like in factored form, or what were my zeros? Good. It was like plus 2, whoops a daisy. Plus 2, minus 2, like this, right? So I had -2, -2, and +2. So now we understand the importance of the number of times it happens, right? When I list that -2 and that +2, I show multiplicity by literally just putting a little number 2 next to it. So if there's no number, it implies there's only happening once. If there's a number there, that means that's my multiplicity. You can use the same notation on your quiz. On your homework, it says this is the root, and multiplicity is, and you pick from a little drop-down menu how many times that root occurs, okay? But you won't have that on your quiz, so you can just write it the way that it is. So what does that tell you about what's happening at -2? It's bouncing off -2, but will cross through +2. Does that make sense? What's the maximum number of turning points?
2.
Max is 2. And then I'm going to graph it. I just graphed it on the graphing calculator on the app so you could see it real fast. Kind of looks like that. So we can see from that it is bouncing off at -2. There's my -2. It crosses through at +2. Okay? And it goes up and comes back down, down and comes back up. That's 2 turning points. You should have been able to figure out end behavior from here too, right? If it's odd, one's going up, one's going down, and it's positive, which means the right goes up, the left goes down. So all of those things are going to help you graph, because eventually, in the next example you're going to see, we're going to put it all together to graph by hand. So you're using a graphing utility to verify, but you will be able to graph these by hand, or you should be able to graph these by hand. Okay, this is your, again, reminder on how to find your zeros on your graphing calculator, but hopefully we're so good at this because we had to use it yesterday that we can go straight to this. So we're going to put all that stuff together to graph these by hand, okay? It sounds a lot worse than it is. I start with the leading coefficient test, which tells me my end behavior. Are they both up, both down, one up, one down, in which direction, okay? Then I'm going to find the x-intercepts by setting my f of x equal to 0. I'm going to pay attention to the multiplicity of this. So all of this is multiplicity, okay? Does it cross through or does it bounce off? Then we're going to find the y-intercept. I'm not going to force you to find symmetry, but symmetry does definitely help in these scenarios. If something's symmetric to the y-axis, then all you have to do is figure out what's happening on the right, and you can flip it over onto the left. So I would say look for things like that to help you, but I'm not going to force you. Like, I'm not going to say what is it symmetric to. And then 5 is your confirmation about the max number of turning points. So n minus 1 is the most amount of turning points it can have. That's just confirmation that what you did is right. That's not going to help you graph it. All right, so graph f of x equals x to the fourth minus 4x squared using what you've learned in this section. So let's talk about f of x equals x to the fourth minus 4x squared. What is my end behavior? Both our arrows are pointing up, right? Everybody understand that? What's my n? 4, which is even. And then the term on the front of that, the leading coefficient, is a positive 1, which means they both point up. Good so far? Okay, then I'm going to find my zeros. So I'm going to say 0 equals x to the 4th minus 4x squared. Okay, how do I factor that? Take it on x squared. Then what?
Then you said x squared is 0 and x squared is 4.
Okay, so you both options are good. You can either factor it further because it's different two squares, or you can split it and solve it. Either way, you're going to get the same answer. So just so that we can see it expand, I'm going to factor it further. And I get x squared equals 0, x plus 2 equals 0, and x minus 2 equals 0. So this is the first time that hopefully it makes sense that it's important that when we square root, we get plus and minus, okay? Because that is not plus or minus. That is plus and minus, which means there's how many zeros? 2. Does that make sense? So the answer is 0, right? Because it doesn't matter if it's plus or minus, but there are 2 of them, which means when I go to list my zeros, I have a multiplicity of 2 on that 0. And then I have negative 2 and positive 2. And those both have a multiplicity of 1. So I go to my graph. So I have 0, negative 2, positive 2. Both arrows point up. My y-intercept would come from plugging 0 in. And I get 0, which makes sense. That's my y-intercept. That is not an additional root, so that doesn't mess with my multiplicity. That's just my odd intercept. The multiplicity tells me I'm going through the axis at negative 2, up to 0, bouncing off the 0, coming back down and going back up. Now, how far down you go in between these points, you can figure out by plugging in one of those values. So if I just plug in 1, God bless you, I get 1 minus 4, which is negative 3. So my curve really should have gone all the way down to there. And I know that it's happening on both the left and the right because of what? This is symmetric. Good. So I could have plugged in the other point or looked at my initial function. If I plug in a negative x, it goes back to positive x, so that's symmetric. All right, start with end behavior. Good. It's going to fall left and rise right. Then do your zeros. How can I factor that? Good. So now I got x squared equals 0 and x minus 9 equals 0, which means x equals 0, and there's how many of those? 2, and then x equals 9. So now I got a point here, and 1, 2, 3, 4, 5, 6, 7, 8, 9, point there. So already I've got this, and I've got this. What am I going to get from my y-intercept? 0. It's already there, right? What happens at the 0? Does it bounce or cross through? Bounces. So it's got to come down, and then it's got to come back up at some point. So as long as you can give me one point in between here, and I would say probably in the middle. So this is 0 to 9. Maybe I'll plot the 4. I would do 4 to the 3rd minus 9 times 4 squared. This is 64 minus 9 times 16. 64 minus 144. Which is negative, is that right? Negative 80. So I know I'm going all the way down, okay? In a scenario like this, just like you did with yesterday's, I wouldn't expect you to go all the way to negative 80 on your graph. You could plot your point and label it.
So you would just draw straight.
There we go, as far down as I could. Yes, and then plot your point, because I'm not going to expect you to go to 80. You could do, you know, by 20s if you really wanted to, but you don't have to. So start with your multiplicity, go to your zeros, go to your y-intercepts, figure out if, start with your end behavior, not multiplicity, end behavior, then your zeros with your multiplicity, then your y-intercept. See if you can graph it. If there's not enough, then you're plugging in points, okay?